Hi everyone, and welcome to episode 16 of the Spark podcast. My name is Jack. I'll be your host, and today we are going to talk about speed. I was reminded earlier in the week about a very peculiar speed-related topic that that I remember from years ago. It's one of these things that was an urban myth, and then you kind of look into it, and it starts to build up a bit of credibility. And this is why I feel like I could be really sucked into conspiracy theories, because some of them, the math just works out. This is one of them. I was reminded about the fastest manhole cover ever. It's crazy. I think it may have been the first ever man-made object to enter space. Possibly. That's a big claim, but I'll tell you the story. In 1956, astrophysicist Dr. Robert Brownlee was asked by his boss at the Los Alamos National Lab in New Mexico to figure out a way to test nuclear weapons underground. Scientists working on Operation Plumb Bob, which is what this one was called, were concerned about the amount of radiation spewed out by the nukes during the tests above the surface. So Dr. Brownlee started experimenting with the idea of blowing up small atom bombs below the surface. He stated that most of the radiation generated in a blast has a half-life of about 4 hours. We figured you could keep everything in, but for a few percent by going underground. But Mother Nature can outwit you in a great variety of ways. Oh, that was a sneaky sneeze. It just came up like in the middle of a sentence. Jesus. Okay. We figured you could keep everything in, but for a few percent by going underground. But for Mother Nature, she can outwit you in a great variety of ways. What Dr. Bob said. Dr. Bob Brownlee. In July of 1957, for an experiment codenamed Pascal A, the team drilled a hole 500 feet deep for what was to become the world's first underground nuclear test. Unfortunately, the bomb yield was much greater than anticipated, 50,000 times greater, apparently. The fucking scientists. Fire shot hundreds of feet into the air from the mouth of the uncapped shaft, in what Dr. Bob described as the world's finest Roman candle, which is quite poetic. He's a bit of a poet, this Dr. Bob. Basically what they needed to do was to cover it over. The next month, in a test codenamed Pascal B, the team wanted to experiment with reducing the air pressure in the explosive chamber to see how that affected the explosion and radiation spread. A 4-inch thick steel cap weighing at least half a ton was placed over a 400-foot deep borehole after the bomb was installed below, and the bomb was then covered over with a layer of concrete. The lid was then welded shut to seal in the equipment. Before the experiment, Dr. Brownlee, Dr. Bob, had calculated the force that would be exerted on the cap, and he knew that it would pop off from the pressure of the detonation. As a result, the team installed a high-speed camera to see exactly what happened to the plug. The camera was set up to record one frame every millisecond. When the nuke went off, the lid was caught in the first frame and then disappeared from view. Basically, the pressure built up inside the chamber so quickly, because what happened when the nuke went off was the concrete over it vaporized instantaneously and became a gas. And that gas expanded really quickly, and there was only one way for it to go, and that was up through the shaft and to take the cap with it. Judging from the yield and the pressure, Dr. Bob estimated that it left the ground at more than 216 kilometers per hour, which is very fucking fast, or more than 5 times the escape velocity of our planet. That's 5 times the speed you need to leave the planet. It may not have been that far, though. It may not have made it that far. In fact, the Boffin, Dr. Bob, who retired in 1992, believes it never made it into space, but the legend lives on, and I kind of believe it. It would be really nice that the first thing we sent into space was a complete accident caused by nuclear testing. But it led me on to the topic of the fastest we can go. What is the fastest man-made object ever? And there's a few different criteria. There's the medium you're moving in. I've broken it into 4. You have water, land, air, and space. And another one of the criteria is, can humans basically be there? Can we go as fast as the things we make? Short answer is no. Not at all. But we'll start with the water one and see how we get on. See where humans really stop. On water, boating can be dangerous. This is in all caps in most of the sources that I found for this one. Trying to be the fastest boat ever recorded is insanely dangerous. I don't say that lightly. It literally has an 85% death rate. People who try to break this record. And it seems like nobody would ever attempt it. But then you have to remember that Australians exist. And they're crazy. And this story is about an Australian man. When you think of the kind of sleek, perfectly balanced craft one might attempt to break such a record in, the last thing you would imagine is that it would be built by an amateur in the backyard of his home, using parts salvaged from random resellers. But that is exactly how Australian dreamer Ken Warby built the amazing speedboat that set the world water speed record. In his spare time, Warby began drawing up plans for a vessel of his own that he hoped would be able to once again break the world water speed record. After 2 years of planning and designing his water rocket, named Spirit of Australia, Warby began actually building the ship in his backyard. He bought the wood and material for his boat piecemeal, as he got the money to afford new parts, and put the whole thing together using mostly hand tools. For a propulsion source, Warby bought 3 small used jet engines from a Royal Australian Air Force auction. The surplus jet engines were capable of pushing over 1,300 kilograms of propulsive force each, which was more than enough to get his ship up past record-breaking speeds. In November of 1977, Warby finally set his first world water speed record on the Blower Ring. It's spelled like Blower Ring, but I feel like it would be pronounced as Blower Ring. I'm going to call it Blower Ring, just because I can. It's my podcast, I can do what I want. Warby finally set his first world record on the Blowering... I said Blowering again. The Blowering Reservoir was a much improved Spirit of Australia. He chose the dammed up lake for the long runway it gave him to get his new and improved boat up to speed. Having trialled and tweaked the vessel over the years since his first test, Warby was able to reach just over 463 kilometers per hour, beating out the previous record holder Taylor by a little over 5 kilometers per hour. He'd finally achieved his goal after years of attempts, but Warby didn't stop there. Having built up a small team of experts during his bids to break the world record the first time, Warby worked with them to get the Spirit of Australia over the 300 miles per hour mark, which is roughly 482 kilometers per hour. A feat no one had ever managed to achieve. He had input from the wind speed expert at the University of New South Wales, and Royal Australian Air Force engineers were able to fix up the old jet engines he was still using so that it performed basically good as new. Warby had also garnered some sponsorship from various companies like Speedo. Fairly obviously enough, you're going to go for the fastest. If your company's named Speedo, it's like an ideal sponsorship to go for the water speed record. And a local department store chain called Fossey's. That one I don't really understand, but I think it's kind of funny. Although the homemade core of the craft remained intact, the sponsorships didn't take over, and he didn't sellout is what I think some water speed enthusiasts may say of Warby, because he got sponsored. Less than a year after he had broken the record for the first time, Warby and the Spirit of Australia returned to Blowering Dam in October of 1978 and pushed the boat to the limit. The craft sped across the water, topping out at a mind-boggling 510 kilometers per hour. Warby crushed his original record and set a standard that has yet to be beaten since 1978. And the reason that it's not being beaten is because people keep dying trying to do it. The thing about getting a boat up to speed as fast as possible is you want to stop the what's it called? It's the resistance of the water. It's when you're braking it. So you want to have as little actual surface contact with the water as possible. So basically these really high-tech speedboats are basically, if you look at them, they look like planes with like maybe 2 or 3 little boats underneath them. That's a really weird image to have in your mind. But think of a boat, right? And at the front of it, there's a little leg. And then there's a little, like, miniature version of a boat underneath that, about the size of maybe 2 man's hands. And then another 2 of those at the back. Or maybe just 1. And that's because basically you want the boat to lift off the water. And you want those hydrofoils, I believe they're called, to make... You want them to basically be your only contact with the water. Because the less contact you have, the less friction you build up, the less work you have to do to move the water out of the way, the less wake you make, and the less resistance there is to speed, the faster you go. The only problem is you've got a very unstable base to be on, and when you're going that fast, water is harder than concrete. So if you falter at all, the boat will flip. You'll smash into the concrete. The boat will explode. It'll kill you. It'll kill everyone within a certain radius because you've got jets behind you. Remember that? You're going to flip over. A jet's going to plow into you and you're probably going to end up on the side of a river somewhere. But yeah, full fucking respect to the man, Warby, going 510 kilometers in a boat. I will never ever do that. Fuck that noise. But still respectable. Now, let's move on to land. Actually, this one is quite recent, but it was done in a very old vehicle. As of August 2018, there's a new world land speed record of 448.757 miles per hour. That's 722 kilometers per hour, which is 212 kilometers per hour faster than water. And what's even more astonishing about the record is that it was set in a 50-year-old car, the Challenger 2, which first attempted the feat back in 1968. The original record run was attempted by legendary speed freak Mickey Thompson, so it's fitting that the new benchmark was set by his son, 69-year-old Danny Thompson, in a refurbished version of his dad's old motor. It was in the same location too, the wide open plains of the Bonneville Salt Flats. If you've ever watched any kind of speed documentary, they're going to mention the Bonneville Salt Flats. It's beloved by speed enthusiasts and the scene of many a good land speed record attempt. Not that I've seen a lot, but there's if you're looking up speed attempts, they're probably on the Salt Flats. In recent years, vehicles on land have clocked even more astonishing speeds thanks to turbojet and fanjet engines. But this one is quite special. This vehicle from half a century ago has beat a 2012 land speed record achieved with a car just using an internal combustion engine. So no jets, no turbojets, no nothing, just internal combustion. Over the past few years, Thompson Jr. has been carefully restoring the Challenger 2, keeping most of the exterior intact while upgrading the internals to match the modern racing standards. This updated Challenger 2 features the same 68 hand-formed aluminum panels as the car sported in 1968, Although the original Ford 427 engines have been replaced by two dry block nitro-fueled Hemi V8 engines that pump out double the speed, roughly 2,500 horsepower or 1,800 kilowatts each. That's a lot of fucking power. 5,000 horsepower. Weighing in at 2,359 kilograms, which helps with stability of the vehicle at high speeds, Challenger 2 burns through 190 litres of fuel in a 5-mile run. That's fucking crazy. It gets like roughly 40 litres to the mile, or 10 gallons to the mile, if you will. That's crazy. That's my favourite fact about that. I don't care how fast you run. You use 190 litres in 5 miles. You're just basically getting a big fucking block of fuel and just throwing it into an engine and just going boom, and just go as fast as you can for as short amount of time as you can. Use it up. Use that energy. Fuck it. Why not? Right. So that's the fastest thing on the land ever. Now we're going to move on to a medium that has a bit less resistance. A lot less resistance, actually, and that's the air. There's not as much friction in air as there is on the land, obviously, though there is still some. And this one is broken into two categories. Speed in the air, because humans are squishy. We're very squishy, very, I suppose, weak to all kinds of force, especially G-forces. Not especially. G-forces are pretty bad. But if you want to go that fast, the human body just can't deal with it. But we do have Lockheed SR-71 Blackbirds, which are long-range Mach 3 Plus strategic recon aircraft that were operated by the United States Air Force. Why was I saying Yukon? They were operated by the United States Air Force. It was developed as a black project from the Lockheed A-12 recon aircraft in the 1960s by Lockheed and its Skunk Works division. American aerospace engineer Clarence Johnson, also known as Kelly to his buddies, was responsible for many of the design's innovative concepts. During aerial renaissance missions, the SR-71 operated at high speeds and altitudes to allow it to outrace threats. Basically, what would happen is, if a surface-to-air missile, a SAM, surface-to-air missile was launched at it, the smartest thing to do in that was to just simply accelerate and outfly it. Just gone. The shape of the SR-71 was based on the A-12, which was one of the first aircraft to be designed with a reduced radar cross-section. If you look up the SR-71, it's basically a very flat object. It's a very flat plane. The only little bulges in it are for the two engines and where the pilot sits. And it was so fast that the only way to get away was just to accelerate. That was the best way to get out of trouble. It was just gone. The SR-71 served with the US Air Force from 1964 to 1998. A total of only 32 aircraft were built. 12 were lost in accidents, with none lost to enemy action that they're telling us of. The SR-71 has been given several nicknames, including Blackbird and Habu. I don't know what Habu is. Google it, Habu, if you're interested. And since 1976, it has held the world record for the fastest air-breathing manned aircraft, a record previously held by the Lockheed YF-12. The Lockheed SR-71 Blackbird has been clocked at 3,529 kilometers per hour. It's a bit of a step up from the speed on land, which was, what was it again? 500 and, oh no, it was 722. Yeah, so from land to air, we have gone from 722 kilometers an hour to 3,529. We basically gained 3,000 kilometers per hour. That's what lack of friction will do. And the higher you go up, the less air there is in front of you, the less air there is, and so there's less friction. You go faster. But the problem with going high up is humans need to breathe, and we're just not built for speed as well, like I said. This is where UAVs come in. Unmanned aerial vehicles. And the fastest speed ever achieved on Earth, if you include the atmosphere of Earth as being on Earth. Although I imagine... Alright, I'm just going to say in the air. I imagine some rockets who have reached escape velocity have gone faster than this. Although this is definitely reaching escape velocity. It's the fastest speed in the air ever. The X-43 was an experimental unmanned hypersonic aircraft with multiple planned scale variations meant to test various aspects of hypersonic flight. That's flight faster than sound. It was part of the X-Plane series and specifically of NASA's Hyper-X program. It set several airspeed records for jet aircraft. The X-43 is the fastest aircraft on record at approximately Mach 9.6, which is 11,854 kilometers per hour. So basically, if you take humans out of the equation, you can go at least 4 times as fast. We're really slowing shit down. 11,854 kilometers per hour. And this is how it achieved it. A winged booster rocket with the X-43 placed on top, called a stack, was drop-launched from a Boeing B-52 Stratofortress. So this rocket, or this booster rocket, was dropped out of a B-52 with the X-43 on top of it. And after the booster rocket brought the stack to the target speed and altitude, it was discarded, and the X-43 flew free using its own engine, which was a scramjet. What a scramjet is a supersonic combustion ramjet. Is a variant of a ramjet air-breathing jet engine in which combustion takes place in a supersonic airflow. A scramjet relies on high vehicle speed to compress the incoming air forcefully before combustion. That's why it's called a ramjet, because it just rams air into it as fast as possible. It's basically, you'll if you Google ramjet, what you'll see is a cross section of it. It gets really thin at the front where the air comes in, and then expands slowly like 2 parabolas. And this compresses the air, and then it releases it again. So the basics of engines, of a 4-stroke engine, which is the easiest way to learn it, you have the stroke in. Imagine your piston in a cylinder. The piston is at the bottom of the cylinder. You have intake, where the piston moves up and it pulls in your, we'll say, a flammable gas. You have your compression, which is when the piston comes back down. It compresses it. And then when the piston comes down, in a 4-stroke engine anyway, it hits a little igniter, in some cases a spark plug, and that creates combustion, which basically explodes that compressed, I suppose we'll call it air, but it's a fuel. That compressed fuel, it combusts that, and it causes expansion and exhaust. So you've intake, compression, combustion, and exhaust. So you intake the fuel, you compress it, you combust it, and you exhaust it. The combustion is where all the power is generated. And this is more powerful based on how hard and how quickly you can compress it, and the force of the combustion, and it's just, you're basically capturing explosions. That's how engines work. Like, if you have a car, what you're doing basically is we found some way to dig up those dead dinosaurs and plants and turn them into this wondrous fuel, put it into a metal cylinder, blow it up, and it makes us go places fast. You know? That's essentially what fuel is. A scramjet is that on fucking steroids, right? Basically, it has to keep up a supersonic airflow. So it needs to go faster than the speed of sound. So it relies on a high vehicle speed to compress the incoming air forcefully before combustion. But whereas a ramjet decelerates the air to subsonic velocities before combustion, the airflow in a scramjet is supersonic throughout the entire engine. This allows the scramjet to operate efficiently at extremely high speeds. The airflow in a ramjet will slow down because it needs to be subsonic, but a scramjet just doesn't care. It just leaves it pass through. So there's like no catching of the air to slow it down, if you know what I'm talking about. You'll know if you look it up. But that's my way of explaining it without diagrams. I've found that being an engineer, it's a lot easier to explain things if I'm able to draw, which may have been a bad way to which makes it difficult to explain things on a podcast. But I like a podcast. It's easy. I like it. But we haven't gotten to the fastest thing made by man ever, unless you count that manhole cover. But this is faster than that. I think it is. I hope it is. God, I hope it is. How fast was that manhole again? Yeah, 216,000 kilometers. Yeah, this was a little bit faster. Basically, if you want to go fast, you got to go to space. It's the only place that we know of that has basically no friction at all. And you can use gravity to help you. Gravity is very powerful. We talked about it a lot in the black holes episode. It's so powerful, it fucks with time. Not many things fuck with time. Gravity does, though. So, I don't think this was the idea of the spacecraft. I know it wasn't, to go as fast as possible. It was called Helios 2. Helios 2 was the second spacecraft, as you may have guessed from the name. There was a Helios 1. Helios 2 was the second spacecraft launched to investigate solar processes as part of a cooperative project between the Federal Republic of Germany and the United States, in which the former provided the spacecraft and the latter the launch vehicle. Although similar to Helios 1, the second spacecraft had improved systems designed to help it survive longer. Like its twin, the spacecraft was put into heliocentric orbit. All communications with the spacecraft were directed from the German Space Operation Center in Munich. Sorry, it wasn't in Munich, it was near Munich. You know, it's the same if you've never been to Munich, in Munich, near Munich, it's all the one. In contrast to Helios 1, Helios 2 flew about 1.9 million miles closer to the Sun, achieving perihelion, April 17th, 1976, at a distance of 0.29 astronomical units, which is roughly 27 million miles or 43.432 million kilometers. A distance that made Helios 2 the record holder at the time for the closest flyby of the Sun. As a result, the spacecraft was exposed to 10% more heat, which is roughly about 20 degrees Celsius more than its predecessor, which doesn't seem a lot for 27 million miles. But anyway, it's space. There's not heat sticking to things out there because there's nothing there. The spacecraft provided important information on solar plasma, the solar wind, cosmic rays, and cosmic dust, and also performed magnetic field and electrical field experiments. Besides investigations of the Sun and the solar environment, both Helios 1 and Helios 2 observed the dust and ion tails of at least 3 comets. Helios 2's downlink transmitter, however, failed on the 3rd of March 1980, and no further usable data was received from the spacecraft. Ground controllers shut down the spacecraft on the 7th of January 1981 to preclude any possible radio interference with other spacecraft in the future. What I haven't said, though, is the all-time speed record is currently held by Helios 2, which reached 253,000 kilometers per hour at its point of closest approach to the sun. That's how fast we can go. It's difficult to get much faster than that. There is a probe, I think it's called Juno 2, that did a similar thing with Jupiter. It got really close to Jupiter, fell into its orbit, and was flung out again. And I think that got to like maybe 1,000, maybe 10,000 kilometers less, 10 kilometers an hour, 10,000 kilometers per hour less than Helios 2. I'm really tired. Oh, I've just realized I sometimes I just stop talking in the middle of a sentence. But this Helios 2 is one fast motherfucker. 253,000 kilometers per hour. That's nuts. It's very fast. It's only a little bit faster than that manhole was, though. That manhole, granted, it wasn't exactly measured, but it went 216,000 kilometers per hour, estimated. It's it's a funny little topic that it just set me down. I went, oh, that's interesting. And I was like, I wonder if it is actually the fastest man-made thing ever. And it's not. That Helios 2 is, which kind of bums me out. But it may still be the first thing in space ever. We got there faster than Sputnik somehow. I have no idea how, but they did. But yeah, now you know what the fastest things ever are. On water, on land, on air, both manned and unmanned, and in space, obviously unmanned. If only we could go that fast, if humans could go that fast, where would we end up? And the answer is nowhere really, because space is fucking huge, and it would take us years to get anywhere, even at 253,000 kilometers per hour. That's how big space is. The fastest we have ever gone is not fast enough. Even if we went the speed of light, which I think is like... Oh, I'm going to Google the speed of light. Just so we know. I think it's 6 million kilometers per hour. Roughly. Yeah, it's 300 million... it's 300 million meters per second. And oh god, it's a lot more than that. It's how many fucking zeros in that? Speed of light kph, just because the commas make it easier to read. It's basically 299.792 or 299,792 kilometers per second. That's how fast the speed of light is. Which is a lot fucking faster than, than that fucking Helios 2. And even if we use the speed of light, the nearest galaxy is 100 million light years away. It's 100 million years. Or is it a million light years away? It's still very far. We're still never going to get there. Unless we develop some sort of wormhole technology. No human can leave Earth and go to another galaxy. Unless we create some sort of colony on a spaceship, and then our future generations may get to the other galaxy, but you won't. You're not going to live for a million years. That's not going to happen. Even if we get to the speed of light, which we won't, because once we get to the speed of light, we'll have time travel, and then it won't matter. That's the theory anyway. And now I'm starting to ramble. Basically, what I'm trying to say is, thank you for listening. If you want me to talk about something else in the future, if you've got a topic in mind that you feel like I could explain probably in a more, not a better way, but in a more obtuse and reckless kind of way, like I try to, get at me on Twitter at Podcast Spark, PODCASTSPARK, Podcast Spark. If not, just comment down below either on Castbox or on YouTube. I don't know if Castbox has a comment section. I'm not too sure, but fuck it, figure it out. Basically, anything you want to say to me, say to me. I'll probably read it because I've got fuck all else to do with my time other than a job and a podcast and running. Yeah. Oh, actually, I should probably talk about this. I have a half marathon, not Saturday coming, but the next Saturday, up in Ackle Island. I'm going to run for 20 kilometres. Me, Jack. Big Jack is running a half marathon. I'm going to do it. I'm not even freaking out about it, you know? I ran 15k, not yesterday, the day before. Today is Wednesday. Yeah, I ran 15k on Monday. And I felt fine. I've got a few blisters, but I'm fine. I've been training for 6 months. I'm up for this. And now I'm saying it to the public, or whoever's listening. Whoever was here for speed, leave right now, because I'm not fast. I'm not fast at all. It took me 2 hours to do 15k. But I still did it. You know, I'm going to try to do a half marathon in 2.5 hours. Which is a very good speed for a regular marathon, but I'm running half that distance. It's going to be interesting. I'm going to enjoy the whole idea of testing myself. So I don't know if I'm going to get to the 20k mark before I have to do the race. I probably will, because I've got fucking a week and a half to get there. And I've got a lot of road. I'm living in the country, so yeah. Right, that's enough about me. Thank you for listening. Get at me at Podcast Spark on Twitter, or comment down below if you want to know more, or if you want to just say something to me at all. Thank you for listening, and bye bye.